The purpose of this video is to present the work on the topic Modeling of Engineering Object and its Action on the curriculum-based discipline Computer Graphics. The authors of the work are third-year students of the Lviv Polytechnic National University, majoring in Computer Science, Department of Computer-Aided Design, Diana Pasternak, Roman Gabowski, Mikhailo Moller, and Vitaly Pesenyuk. Let's begin by considering the agenda. Describing this process, it's necessary to start with the objective and description of the tools used. Then, I would like to take a look at stages of implementation of a given task. The objective of this work is to create a three-dimensional model of car and compose the event in which it participates. Designed event is the car movement around the city and parking in the structure. On this slide, you can see the picture of car, which is the reference for further work. Now we will move on to the tools and technologies applied. To perform this task, we used an open-source 3D computer graphics software toolset called Blender. Blender is used for making animation, gaming, and visual effects. We used Blender for creating a car model, establish the city scene, and as an environment to write Python-based macros. Resulting videos were made also using Blender rendering tools. Blender embeds a Python interpreter, which is started with Blender and stays active. The interpreter runs scripts to draw the user interface and is used for some of the Blender's internal tools too. Blender provides the BPY module to the Python interpreter. This module can be imported in the script and gives access to Blender data, classes, and functions. Scripts that deal with Blender data will need to import this module. At the outset, we implemented a model of Bugatti Chiron without referring to specific dimensions and scale, and carried out a photorealistic rendering. Pictures on this slide show the stages of creating a model, distorting a plane to form a car body, building wheels and linking them, establishing other parts of car. Now you can see the parts of texturing process with help of shader editor. Let's take a look at demo video of car model. There is used some studio light to make it look more realistic. This effect is achieved by placing planes with light emitting texture around the model. These planes are attached to the car body, so they move with the whole car through the city. Cycle's render engine helps with reflecting all the shades and bleaks, as it provides physically based results out of the box, with artistic control and flexible shading nodes for production needs. The city scene has been designed with help of imported models of houses and other objects like lanterns, sidewalks, parking lot. The first step was to create a plane that would reflect the texture of the asphalt and place it along the curves. Marking has been performed on a similar principle. Sidewalks have been created from individual plates with the appropriate texture placed along the curves according to the road bendings. The parking lot has been also marked, various objects has been placed around it, fences, barriers, lanterns, etc. To make the city scene more realistic, several imported car models have also been placed. Some of them are parked, some are moving around the city. Now let's consider the physical base of performing different movements of the object in detail. When turning, the rule of the slower rotation of the wheel moving on the inner radius is ignored, because it has been decided to create a model of the car which is equipped with a wheel lock on each axle. It means that the wheels on each axle rotate at the same speed. Mainly, the back wheels of cars do not rotate, but this car model has the option of separate wheel pairs rotation. The front wheels must be rotated in the way the extension of the axle of each wheel is directed to the same center. Therefore, for good handling, the front wheels must be rotated at different angles, and they are going to be non-parallel. The Python macros has been written to the model perform some actions. Actually, it manages the movement of the car, setting the trajectory, wheel angles, vehicle brakes, and stops. Let's dive into the features of practical implementation slightly. The role of the piece of code demonstrated is to move the car on the fourth section of the trajectory. Moreover, this code manages the rotation of the wheels according to the time. To perform this, at any given time, a point is taken from the array of all the points of the fourth pass, and the coordinates of this point are assigned to the center of the car. In order to perform the rotation of the wheels, the value of the angle of rotation has been applied per unit time, and it increases at any time. Here you can see the resulting event that has been implemented. The straight run changes to a section with 2 consecutive turns. The car passes them without changing the speed. While approaching the T-junction, the car starts to slow down to a complete stop in front of the stop line, fulfilling the requirement of the stop sign. After that, the car performs a left turn, gradually increasing the speed. Before getting off the main road in direction to the parking lot, the car reduces its speed and turns right at a steady speed. The car brakes and stops in front of the gate. A barrier rises in front of the car pulls in the park at low speed and parks in a vacant lot. Finally, here is the list of sources we used to perform this pretty exciting and fascinating task. Thank you for your attention.